The future of the automobile requires collaboration, but how do you unite a loose collective of potential frenemies around industrial innovation?
Through the network effect.
Hello, I'm Michael Hainsworth.
ARENA 2036's campus in Germany is the largest research platform for mobility in the world. It's at the intersection of where science and industry meet to develop next-generation vehicles. Meet Dr. Clemens Ackermann, Deputy Managing Director at ARENA 2036 in Stuttgart. He's managed to get 57 automotive partners, including the world's most influential automakers, all under one roof.
When I open the door of my car and I go in, I'm all of a sudden immersed in numerous digital worlds, potential digital worlds. And something like that, a thought like that, cannot just occur to one actor, but we have an entire consortium thinking and tinkering what is needed to actually make that threshold moment enjoyable and recognizable, both ways, in and out of the car.
Was it difficult for ARENA 2036 to convince the world's leading competitors to work together?
Well, it was a challenge at the beginning, I want to say, especially before we actually had the facilities that we have today and that you see right behind me. We started out with only 7 partners in the beginning. Daimler, now Mercedes-Benz, was one of them, so we already had one of those big fishes caught. We realized though that from 17 partners onwards, which was about the number of partners we had when we moved into this facility, a dynamic started to develop in the ecosystem. And from there, we were then able to scale up to 57 partners as it is today.
The auto industry has a history of being secretive and insular. Concept cars, they're closely guarded, and talent is often poached from competitors. Weren't the car companies worried that a great idea would be used by their rivals? How do you unite a loose collective of potential frenemies around a promise of industrial innovation?
That's an excellent question. So, first of all, I have to say that we're not just focusing on the next generation of automobiles. We're also focusing on the way of how they are being built. So one of our heavy focus is on production research. And the production people are much less secretive than the product developers. When it then comes to product development, though, we are looking at next gen technologies. We're not trying to think of what could be in the car in 5 years. We're trying to envision what the car would need in 15 years plus. And when it comes to that kind of horizon, we're more or less in a pre-competitive environment, which takes away the edge a little bit and which helps people to open up.
Give me an example of what ARENA 2036 is doing today that will end up in a vehicle tomorrow. Give me a concrete example of something where in the future somebody's going to get into their vehicle, remember this conversation and go, oh, I knew this was coming.
One of the things that we're really strong at is the entire wire harness business. The wire harness is a component in the car that just organically grew over the last 130 some years. It's monstrous. It's incredible in design, and not a single engineer who would sit down today would design it even similar to what it looks like today. So what we're doing is we're trying to help the entire wire harness branch to start robotically handling the flexible parts, to build an asset administration shell for the entire wire harness, to think about different architectures for the wire harness, to include glass fiber optics in the wire harness, and to then eventually have a wire harness that is built in high-wage countries because of the automation, because it's that is at the same time much lighter because the design is more clever, and that will, at the end of the day, be one of the absolute enablers for autonomous driving. Because without automation, I would need a quality management, ingoing and outgoing, that would just be insane. With the robotic handling of the cables, I can do a lot of the quality management automatically. So I'm coming to realize that I'm describing an innovation, a potential innovation that will be in the car but not seen by a single driver.
Right, exactly. So you get in the car, it's not going to be a new button, it's not going to be a dial. It's the infrastructure that makes all of that sort of stuff possible in the first place, that the consumer will probably never ever see. You know, when you buy a new house, you're not asking yourself, well, you should be, but you're not asking yourself about the electrical wires running through the home. When you walk into a business, you're not thinking about the Wi-Fi. You're essentially building the next generation network inside the car.
Exactly. And at the end of the day, it's obviously up to the OEMs to think about what the architecture of the wire harness will be. But the standardization that is coming beforehand, that's where we're strong and that's what we're driving.
So what is something you found that you've discovered working collaboratively that is going to help make the vehicle of 5, 10, 15 years possible?
What we see is that traditionally we would formulate our roadmap for a project along milestones and then work sequentially from milestone 1 to milestone 2 to milestone 3 to eventually reach the goal of the project. What we're trying to do here is get away from that sequential way of working and parallelize the efforts. And we can do that because we're trying to open up the projects themselves. We draw them up as platforms where we open soft and hardware interfaces of a lot of the different projects, and then have the entire ecosystem seeing the demonstrator, being able to contribute their own technology to the demonstrator. And we are still pursuing an initial project plan, but we have a lot of parallel lines with a lot of additional milestones that just happen serendipitously, I would say.
What about the vehicle itself? I'm fascinated by the idea that you're developing car components that know what they are, what their role in the vehicle is, what their capabilities are, and then they share all that information with the other parts of the vehicle. What does that component-to-component networking capability do?
Oh, that's one of the topics that I like a lot. And so this is something that we call cyber-physical systems or cyber-physical components. And it's exactly what you just said. They know what they are and what they're capable of. And with that knowledge, they're capable of self-description. So by the time I would plug in a single component into a cyber-physical system, the entire system would recognize the component not just as a new component, 0, 1, but it would recognize the component including all its capabilities. If we then have standardized interfaces, what we could think of, for instance, would be a upgradable car. We could seamlessly exchange video cameras, for instance, in the car, and would not have a certification issue because the cyber-physical system could then self-certify. So that is something that a lot of our partners are working on, and they're not just working on that within the field of the automobile itself, but also within the realms of production. But that is something that is incredibly promising, and there has already been a lot of work done, but I'm sure that we will hear a lot about this.
There's so much talk about the fact that the automobile has evolved to essentially be a skateboard, you know, 4 wheels, a platform, and then you add anything on top of that. But I suppose what you're talking about now is the adding things on top of it. It's almost like you're creating a Lego-like environment where you can do plug and play for different, and sometimes I can imagine competing components.
Yeah, and I mean, just technologically speaking, from a research perspective, a lot of that can already be simulated or tested. The really interesting thing will be after TRL6, when we're actually looking into what's the market potential. And there the OEMs then will start talking about this as well, differently than they are now that they're still involved in the research, because an upgradable car would change business models. We already see that in the field of digital extras for automobiles. Audi was really strong with the e-tron there, where you could just book different options for your car as one of the first ones on the market. Tesla, the App Store on wheels, as they called it, most definitely too. But that's just updatability on software from a software perspective. If we also do that for the hardware, we have certification issues, we have business model issues, we just have a host of questions to answer when it eventually comes to TRL7 and beyond.
And I can imagine having all the major automakers under the same roof, able to have that kind of conversation, accelerates the innovation that comes with the kind of business you are involved in.
Well, the two automakers that are mainly involved with Arena 2036 are, on the one hand, Mercedes-Benz and then the BMW Group. The BMW Group is currently focused on the initiative, on the wiring harness initiative, and the colleagues from Daimler Trucks are also a part of us. Now, the seamless exchange on the shop floor can certainly enhance the discussion about different kinds of topics, but what we cannot claim is that those three come together and they develop the next generations of cars. They have very specific focus areas when they're working in Arena 2036. They have very focused experts that are working in those areas, and they are answering very individual questions, but use the power of the network in order to do so.
So 2036 marks the 150th anniversary of the automobile. So what would you say the biggest evolution of the car has been over just, say, the last 50 years?
Oh, that's a fantastic question. There are a number of really impressive technological changes in the automobile. On the one hand, it is more and more turning away from just being a device that gets us from point A to point B, but it is an extended space where we actually live. We spend a lot of time in our cars. We increasingly spend time in our cars. We see in China people renting cars not to actually drive them, but to spend time in them, to use them for video conferences, to play PlayStation or Nintendo or something like that, to use them as karaoke bars and all of those kinds of things. So we are more fully integrating the vehicle, not just as a means of transportation, but as a space that we use to live in our lives. That's certainly a development that we do not see fully fledged in Europe or the Northern Americas yet, but it is something that we can already observe in nascent stages in the Asian countries. Technologically speaking, I would say that there are a lot of things along the lines of connectivity that allow us to more seamlessly interact with our vehicle, that allows us to continue what we started on our computer, took with us on our phone, to just seamlessly continue in our car. I think that was a really big achievement, and we're just seeing the rollout of a lot of new technologies in that regard. And I suppose that what we can expect over the upcoming years is that the virtual and the actual reality will meld more and more together.
That's fascinating, because when I bought my most recent car, it was the first one to come with CarPlay. And I felt like I didn't buy a car that talked to my phone. I owned a phone that talked to my car, and that the vehicle was an accessory to the phone, like a case would be, or some add-on functionality. It sounds like what you're saying is that we really have, over the last just 50 years, managed to find ourselves using our vehicles for more than just driving, as you point out. Some are using them as karaoke bars. But it's really fascinating that we've managed to work together on a lot of this stuff and make the vehicle about more than just getting from point A to point B.
Yeah, we have a project here that we just started that builds on another project from the past called CarPulse. And there we're trying to figure out what happens when I move from one physical reality into potentially infinite number of digital realities. So when I open the door of my car and I go in, I'm all of a sudden immersed in numerous digital worlds, potential digital worlds. And something like that, a thought like that, cannot just occur to one actor. But we have an entire consortium thinking and tinkering what is needed to actually make that threshold moment enjoyable and recognizable, both ways, in and out of the car, but then also with the technology included. And on the one hand, it is the extension of the smartphone that you're entering there, but on the other hand, it might just as well be the living room that you're taking with you from your home onto your travels.
This sounds like it requires self-driving cars. It sounds like what you're saying is we're just going to get into our car and the last thing on our minds is going to be driving. Do we need autonomy for the kinds of technologies you're working on at Arena 2036?
I don't necessarily think that we do need autonomous traffic in order to use the technologies that we're already working on and that a lot of people are working on currently. Obviously, in a complete autonomous traffic scenario, they would come to full fruition, so to speak. but there are just so many things that we can still use that enhances the experience of the driver, that enhances the experience of the passengers in the car, that makes the car more usable and enjoyable whilst it's not moving, and that makes it just so much more connected to ourselves, to our other devices, as well as to our home, for instance.
So help me understand your world a little bit more. You have joint projects, focus projects, and speedboat projects. I understand joint and focus, but what's an example of a speedboat project? You're not making actual self-sailing boats, are you?
No, I actually can't even tell you anymore where the entire nautic vocabulary came from, but the general thought of the platform is we want to increase the speed from an idea to the start of a project. We want to make the project itself more efficient and then shorten time to market eventually for our partners. So the headline, you could say, is we try to shorten the time that it takes from an invention to become an innovation. With those different types of projects that we have, we lay the ground for different layers of depth in the projects. With those joint projects that you were mentioning, we typically have a duration of 5 years. Those are projects that are publicly funded, and they are, so to say, the strategic backbone of Arena 2036. Those are 4 projects with large consortia and with public funding involved. The focus projects then are typically larger in capital volume, but shorter in time. So there we're only looking at 36 months. They're a tad more flexible. The infrastructure, the architecture of the project is a little more open, and we have just many, many more of them than just the 4 of those joint projects. Now, the speedboats are the projects that we love most because we don't have to track them. What we did in order to enable them was we created a legally safe space where every single member of Arena 2036 signed the bylaws, the IP regulation, the NDA, all of those documents, the antitrust rules. And by the time a developer has an idea and he just finds enough other researchers and developers to make a POC or to just see whether or not it's feasible what he or she was thinking about, they can start. And those projects typically are very small in capital volume. We're talking 60 to 100,000 euros. The goal really is an MVP or a POC, and they're typically done after 9 to 12 months.
Arena 2036 is not just developing technologies for the next generation of automobiles.
The network effect comes from the collaboration among the brightest minds in the auto industry, all wired together. There are multiple layers of network connectivity in the auto industry. We've got network technologies for the production of the automobile. A separate networking technology takes over once the vehicle rolls off the assembly line. And networking between vehicles on the road promises to be as big a leap in safety as the seatbelt was in 1958.
When Saab introduced them as standard equipment.
Let's start with the factory floor. What role is Nokia's network expertise playing in the collaboration stage?
Nokia for us was an incredible win for the entire network, for the entire network Arena 2036. When Nokia came in saying that they're fantastic at sending data, fantastic at receiving data, and there's no doubt about the fact that they are, but what they needed were use cases where the 5G infrastructure would actually be used. And the general thought was, what if we placed a 5G campus network at Arena 2036 and just gave free access to every single member involved? We currently, to my knowledge, have 20 of our partners actively using the Nokia 5G infrastructure here. And the use cases range from robotics to intralogistics to autonomous driving to pretty much everything that you can imagine within a production scenario.
So as the network collects data from your research projects, how is that data used?
Data usage, data collection is still one of the really tricky questions. We're hoping that eventually we'll end up with a data space where all the research data will be stored. We have an identity management, and every single member of Arena 2036 can do exactly in the digital space what they're already doing in the physical space, meaning they can exchange knowledge qua data. The way it currently works is that we oftentimes have consortial agreements or bilateral agreements whenever Nokia is engaging with any of our partners, now in the case of the 5G network. And what Nokia is then doing is they're dynamically specifying the network for the individual applications, and the partners that are using the network can actually do their applications. So it's a win-win situation, but we're not quite at the point where we can say we have a central storage for that data, that we could use it, for instance, to train AI algorithms.
Right. It sounds like sort of the next step is you gather all this data and then you build out things like digital twins that gives you the ability to build out metaverse-like functionality as well.
Yeah, so one of the next steps for us will be, we call it Arena X. It will be the data space for Arena 2036. We already have a digital twin, for instance. We're cooperating there with a different company that makes a laser-based point cloud of Arena 2036. But it's always bilateral relationships whenever someone wants to use that point cloud for intralogistic purposes. And our wish would be the point cloud would be in the data space. Everyone who needs it can access it, and vice versa. The other company would then benefit from all the use cases that build on their point cloud. So that is definitely something that we're working on. That is something that not just us. There are a lot of publicly funded projects in Germany, in the EU, but we think that we do need something like that to actually start seamlessly exchanging data across value chains, and especially needed for research purposes.
Once a vehicle is in the hands of a motorist, what role does 5G play?
5G starts playing a role even before the rollout of the vehicle. What we are currently doing a lot here is indoor autonomous driving. So as soon as a car has tires and can walk, has a CPU and can think to a certain extent, and has sensors so it can see, we said, why there's no reason to put it on an AGV or to have large robotic lines where the car can be taken from job to job. Why is it not driving there by itself? And so we're using the Nokia 5G infrastructure for a project called FlexCar, where the rolling chassis with really just, it was a skateboard with eyes, a brain, and wheels, would autonomously drive from production job to production job. After that, we're thinking about the handover. We do not just have an indoor campus network, we also have an outdoor 5G network. So we can simulate handshake scenarios. So what happens if the car goes from indoor to outdoor? And how can we flash software in for the car? Currently, a lot of automakers are still plugging in and pulling out the plug it in, pull it out. Eventually, you have it in the shop. And if you come as a customer, they say, we first have to update. Why is that not happening over the air? For those over-the-air topics, 5G will play a central role in production, in delivery, and during the life cycle. And later then, 5G will play a role for the updatability that I just mentioned, but might also be a very strong enabler for autonomous driving in a variety of different fields.
And I can imagine that part of that is vehicle-to-vehicle communications. What kind of advances has Arena 2036 made?
Well, it's vehicle-to-vehicle and vehicle-to-infrastructure communication, really. So we are really working with partners on vehicle-to-infrastructure, or used to work on vehicle-to-infrastructure communication, where it was about pedestrian safety. A lot of it was about pedestrian safety. We had a couple of play-around projects where vehicles could tell their mood to other vehicles. That was just goofing around, though. For us, the connectivity from the vehicle to the driver, from the driver to the vehicle, is more important because we are simulating in a lab environment, not in the open streets. And much more important, or much more weight for us, is in the machine-to-machine and worker-to-machine connectivity within production scenarios, actually.
Once a car is parked in my driveway, what's the significance of vehicle to home?
We're talking about how you experience the car to be an extension of the device that you're carrying with you all the time. The seamless communication between the different devices that we're using on a day-to-day basis becomes more and more important. So if I have a phone call in my car and I want to continue that phone call when I go into my house, and I mean video phone call, video conference, there should be capabilities or possibilities for automatic transfer as one example. Another example would be if I have solar panels on my roof and my car is in the garage, it should be so intelligently integrated that I can bidirectionally use my car as battery for my house to use it as well. We're not doing that yet for a variety of different reasons, but that is one of the things where I think that a car to home connectivity would make incredible sense. If it all of a sudden is, while it's not used, it's just the battery for my house, it's sustainable, it's green, and it just puts it more to use.
Leveraging the power of the network effect means we're getting safer, more efficient vehicles powered by Wi-Fi, fiber, 5G, and 6G.
So how is Arena 2036 leveraging all of this data being shuttled back and forth, and what does that mean for the next generation vehicle?
We are in a very fortunate position that we do have different cutting-edge technologies on site that the different partners can use. So they can use it to bench them against each other for individual use cases, but they can also play to the strengths of the different technologies. When we look at indoor navigation, for instance, different technologies offer different precisions in navigation. And combining those technologies then gives me a maximum speed with simultaneously the maximum precision and the maximum safety. So that's Wi-Fi 6 and 5G mainly. When it then comes to 6G, which you just mentioned, with 6G, we are just starting with Nokia. Nokia is mainly starting to work on 6G sensing technologies. And the incredible thing about it is that 6G then builds a mesh where the network becomes aware of its environment. So it knows what's around. It can detect people walking around. It can detect forklifts driving around. It can detect installed machinery. And it will just give me a very, very precise map of all of my surroundings. A map that currently we have to rather complicatedly draw up manually.
Help me understand that a little bit more, because it sounds to me like what you're talking about is very much a LiDAR-style capability that is capable of recognizing a person walking in front of a vehicle or somebody enters a room as well. Is this almost a replacement for that kind of sensing technology for autonomous vehicles, or is it an adjunct that complements it?
That's an interesting question because I don't know. There are just so many technologies competing. There's LiDAR, there's radar. The radar proponents say, well, radar has advantages compared to LiDAR because the LiDAR people say, but our advantages are different yet again. Now, with 6G, there are obvious advantages compared to LiDAR when it comes to the mesh capability of 6G, when it comes to the fact that LiDAR is always fighting with bad weather conditions or with a lot of snow or with reflections. 6G does not have that problem. But at the end of the day, or from what we observe today, sensor fusion, I believe, is probably one of the things that we will see a lot of.
Oh, that's interesting. The idea that we're not just going to pick one technology, we're going to incorporate all of them and use them all together.
Yeah, it has two advantages. On the one hand, we play to the strengths of all the individual technologies and get just so much more precise. On the other hand, we have an automatic redundancy, which we need for certification, safety, and security aspects. So I think that the fusion of the different input signals is something that we'll see more and more of.
Let's talk a little bit more about leveraging the data from these networks, because you do have this physical space. What about the leveraging of the data to replicate that co-location in a digital space?
It was around 3 to 4 years ago that all the X initiatives started. It was Catena X as one of the forerunners in Germany. It was Gaia X on a European level. Now we have Manufacturing X, Factory X, all of those X's. And all of those X's are dealing with the question, how can we transfer data seamlessly across the value chain? There are precursors from the legislature which forces people to exchange data when it comes to you have to prove that there was no child labor involved, you have to prove that your product is actually sustainable, you have to know where your product is at the end of its life cycle so you can take it back and recycle it. So there is a dire need to be capable of doing that. But on the other hand, there is also the question of, well, how are you going to do it? Because the data that you have and that you produce is often cases one of the assets that is part of your business model. Oftentimes it is something that you want to protect. And the biggest question is who's going to make money with providing a data space? So we're trying to create a data space in a somewhat sterile environment where we don't have to ask the last question, the business question, who's making money with it. But we want to provide a data space where people can seamlessly exchange research data in order to learn what they will actually need on the market eventually.
Is it safe to say that without the network, Arena 2036 wouldn't be possible?
Well, there are two networks then. Without having the network of partners that we have, Arena 2036 would not be possible. Without the 5G network we have on site, a lot of the use cases that we're working on, a lot of the projects that we're working on, and a lot of the integration that we have on site on campus, and a lot of the attraction that the campus has, especially to SMEs and startups who would otherwise not have access to a 5G network, would not be possible as well.
If there was one takeaway for someone watching our conversation today, what should it be?
Well, it should be leverage the network effect.
So Clemens Ackerman and his team at Arena 2036 have figured out how to drive innovation in the automotive sector through the network effect, both literally and figuratively, by finding common ground, establishing ground rules, and by leveraging networking technology to share data and a future that gets brighter every day.
Hit the subscribe button because the road ahead promises to be an exhilarating ride into the future of automotive innovation. This has been The Network Effect. I'm Michael Hainsworth.